Hey guys, welcome to TOC. This is Abhishek out here. In this lecture, we are going to understand what is a linked list. We'll cover the one-way list, and we'll start some coding once we understand it. Well, a linked list is a collection of nodes. This is the schematic diagram of a linked list. These are the individual nodes, and these are connected using pointers. And each individual node should have minimum two fields. First field is called the info part, and another field is called the next pointer field. Next pointer field. This part is going to hold the real data, and this part is going to hold the address of the next node. Okay, so if we look closely, then it should be something like this. The address of this node is going to be kept here. Again, the next node, the address of this node should be stored here, and the address of this node should be stored here. Each individual node should have any number of fields. Out of them, one field should hold the address of the next node. And to signify that that a particular node is the last node of the list, so that pointer field should be marked with a null value. This is the last node, the last node, and this node, the next pointer field of this node is null. So if we want to create, say, if we want to create a linked list of three nodes, say it is these are the nodes of a linked list. These three are the nodes of a linked list, and if its name is A, this is B, and this is C. So the algorithm should be, we create A, B, and C, three different nodes, and we store the address of B in A, the address of C in B, and the next pointer field of C should be marked with null. So let's start some coding. The way we create a node of a list should be, well, we use Java scanner class to accept the input from keyboard. So let's import it. Import java.util.scanner. This we have imported, and then we have to create the nodes first. So a node could be declared as class mylist, and we want two different fields. First one is the info field. For our convenience, I'm going to hold I'm going to store the integer data. So info field, this is the first field, this is the first field, this is the first field, and this is the first field of node. And now the second field, which is called the next pointer field, which should hold the address of any other node. So all the nodes should have the type mylist, so we should create a reference variable, mylist link. This is the next pointer field, and this may be called as info part. This is the info field, this is the next pointer field, and it's a good practice to initialize this link by null. So let's call a constructor mylist this dot link should be initialized with null. Okay. We have created the node. When we create the object of this mylist, the node is going to be created. So the name of the file is linked list demo. So we are going to create a class linked list demo, and in here click static void main string is the end of class is the end of main function, main method. Okay, this is done. Now we have to create the nodes. The node we can create as mylist. First we are going to create the node A. So the algo should be algo first step, create nodes, place data into the info field, and third is link the nodes. Okay, so we are going to cover the first step. Well, my list A equals new my list. This will create node A. My list B equals new my list, and my list C equals new my list. We have created 3 different nodes. Creation of nodes. Well, the nodes have been created, and now we have to store the data into the info field of the node. So storing the data into the info field. So let's create the object of scanner class. Scanner s equals new system.in, and now let's ask please enter the data for the info field. And of node A. Okay, so it could be done as a dot info equals s dot next int, and similarly we'll store the data for field B, node B and node C. So node B, this for node B, and this for node C. So this node B, this node B, and b dot info, so that in info part of B it will be stored. Okay, we have stored the data in all the fields. So we have created the nodes, 3 nodes. Node 1, this node A, and this node B, and this node C. This node A, this node B, this node C. And we have stored the data also, say it is 10, 20 and 30. Now the linking logic, these two parts have been done, and now the linking of the nodes. If we check, then we'll find that the data have been stored in the individual nodes, and now we have to link the nodes. Well, as I said, the linking could be done as we need to store this address in this address in this. So we should write something like a dot link equals b dot link. So this is going to be linked, and b dot link equals c. So c is linked, now c is linked with b, and in the constructor we already have initialized the link part. So while creating the node itself, all the link part have been initialized with the null, so no need to initialize the link part of C after linking the nodes. So now the linking of nodes, well, it could be done as a dot link equals b dot link equals c. We have linked all the nodes. So if the nodes have been linked in, so okay, let's print the content of A. Print the content of A dot info. So the name of our file is linklist.java, or we could do it as java c linklist demo.java. So it could be done as a 10, 20, 30, the link part. Now the question is, if all the nodes have been linked in, then we can print the data of B using the node A. Let's check. So could it be done? A dot link, no, wait, A dot link dot info. Which part it's printing? 10, 20, 30. It's printing 30. And now a dot link, what does it give? Ten, 20, 30. So definitely all the nodes have been linked in. Now we can use any loop, iterate over, and print all the contents. So let's use while loop. While, well, here I am using a not equal to null, and don't use println. We have to print in some systematic way. So let's do something. Println and \n/t, and in here a dot info will it print a equals a dot info, a dot no, don't do this. Simply print null, so that it will show that the end of the list have been done. Null. We have iterated till the end. So this part is going to print the contents of the list in a systematic way. This is how we print it. And the most important part is, well, we are printing, but we are not advancing. Basically what we are doing, we have created the list 10, 20 and 30. The list have been created, and we are not it will print the content of A, but again it is going to print the content of A itself. And since we are not advancing, so at any point this is going to be true, and it'll result in memory loss. So let's advance the pointer. So A should be updated by a dot link. So let's print it 10, 20, 30. So the list have been created, and now we can create a linked list using this kind of this for understanding the linked list. Now let's create a linked list in using some interactive way, so that we can understand like how to create a list and how to print it. Now one thing I would like to tell you, that without using, okay, just wait, I didn't save it. Instead of using these different names A, B and C, using the name A itself, we can create the list. As we know that we can store the address of node B. We can store the address of node B in node A. So we can create the list a.link equals new mylist, and the new node will be created, and along with that it will be linked also. So we will not if we'll not write the linking logic also, the nodes will be interlinked. So let's do that. Okay, so here a dot link equals new mylist, and a dot link dot link equals new mylist. So a dot info, that is fine. A dot link dot info is also fine. Now a dot link dot info. So this is for the first node, this is for the second node, and this is for the third node. So this is done, and no need to link all these nodes. So if we print the content 10, this is done. So this is another way to create the list. And now let's comment this code. Comment this code. Now we have to create a linked list. So for that we have declared the node itself in this class, and let's take a character char c, and then my list say it is take it as sc, scanner sc. Let's create this start node, my list s equals new my list. This we have created, and now we can instead of writing my list again and again, we can call a method also, and we can create the node every time by calling the method itself. So any other node we should take, we are just taking the reference variable, so that we can iterate using that variable my list, this temp, take this temp and store s in that. And now we have created the node. Let's take the data for the info field of s. So system.out.println, please enter the data for the info field, and ts.info should be sc.next end. The data have been stored. Now let's start a loop where we'll ask interactively that do you want to create node, press y or n, like this, while true, and in here is the end of while loop, end of while system dot out dot println and to add node, press y else n, and store that choice in sc.next dot char at c.next char at 0. Now we have taken in the choice. Now ask if c double equals, this is a character input, so should put it in single quotes. Sorry, this is not capital N. If it is so, then simply break. If not, then my list L equals new my list L equals new my list, and we have to place the data also. So ask println to store the data, please enter the data for the info field L dot info equals sc.next end. The data has been stored in. Now we have to link the nodes. So this is S, we place the data 10. This is L, we placed the data 20. To link, L should be assigned in s.link. S.link should be updated by L. Now as we are using iterative process, we are iterating this while loop, so this L should be updated by S. We are going to use this L as in the name of S, because every time it will iterate and create the new node in the name of L. So S equals L, and the nodes have been created. So outside, now the point over here is, why did I take this temp variable where I stored the variable s? This is because every time it will iterate, s will move till the end. Okay, if I don't use this variable for the iteration, what is going to happen? Let's check. Let's use a while loop. While s not equal to null, system dot out dot print s dot info s dot info, and s equals s dot link, and outside out dot print and the null. Okay, so anything else? Do something println, so that \t, don't do this, \n, and so you have done all these things. Let's try printing the what is this? Error expected where? 97. Where is the line 97? Huh? White. Okay. Ten, 20, 30. Oh, sorry. My error. 10. Yes, I want to add 20. Yes, I want to add 30. Yes, I want to add 40. No, I don't want to add. Why? Why it's printing 40? Because now s is pointing the last node, so only 40 got printed. So in order to do that, let's do something. We need to store the start address somewhere else. So this is what I did over here, and it's always a good practice to not change the content of t. So s should be updated by t, and now let's print it. Okay, so please enter the info field. So the node have been created. Say it is node s. So if I print 10 got stored in over here. Now if I want to create one more node, so press y. I pressed y, so one more node got created, and it's asking for the info field. 10 20, I put 20 got stored, and due to this logic it's getting linked also. It's getting linked, and now s in the name of L it got created, in the name of L it got created, and s is pointing this also. Now the name of this node is L and s both. Now in the next turn again, if I create another node, then L will be the name of this node, and we place the data, it got linked, and s again will point this node, not this and not this. So at the end of the iteration, L is going to point the last node. Here it's going to point the last node. So that is why I use a temporary variable where I store the value of s. Sorry, temporary variable t is going to be assigned here, and since this is the start address, this is the address of the start node, so right from the start node we started iterating the list. Now another thing is, without using this new name L, we can create the node as we have done. So it could be done as s dot link equals new my list, and no need to do the linking part. So ls dot link dot info, and we need to update the name. So s equals s dot link, because s dot link is representing the next node. So it could be done as s is equal to s dot link. So this links the node. So it's done, I guess. Well, let's print the ten, yes, 20, yes, 30, yes, 40, no. It's done. So we have created the linked list two different ways. This is the basic way. This was just for the basic understanding, and this is a full-fledged code. I hope you enjoyed. Thank you, gentlemen. God bless.